Hello and welcome. In this video, we're going to talk about conduction through cylinders and spheres. So basically, conduction through cylinders and spheres have the same concept with the conduction through plane walls, wherein conduction through cylinders and spheres also obeys the law of Fourier's law, but it is in radial coordinates. So let's write Fourier's law again. Our Fourier's law is Q equals negative Ka delta T over delta R. So you can notice that instead of writing delta X, which is the thickness of the plane wall, we're going to write it in delta R because that is the one varying in this uh, subject or lesson, wherein the wall of a pipe, say for example, wall of the pipe, the thickness of the wall of the pipe is varying. It depends whether how many insulation or material you're covering the pipe. So to solve for this equation, we need first to identify our circumferential area. So taking note, for example, we have a pipe with length L and a radius R. So our circumferential area will be A is equals to 2 pi RL. So paano nga po ba nakuha yan? So makukuha natin itong circumferential area na to by making this pipe cut in half. And it's like i-open po natin siya na parang ganun sa wrapper ng isang tin can. So if we cut it in half, magiging itsura niyan, magiging rectangular po siya. Wherein itong length na dito sa baba sa kataas is yung length L, same po dito. And itong width niya is magiging yung circumference po nung pipe natin, which is 2 pi r. So getting the area, we will get length times width or length times yung circumference nung pipe, which is 2 pi r times L. Now, let's substitute in the Fourier's law. So, Q equals negative K times 2 pi R L times dt over dr. Now, let's get rid of those derivative. So, separating the variables, Q, mas multiply po natin yung dr, tapos yung r, para ma-separate natin yung variables. Then, leave natin yung constant dito sa right side, which is k and 2 pi L dt. Okay, so integrate natin from point 1 to point 2, or from inside to outside. So in this case, kaya tayo nag-integrate kasi meron nga pong thickness and change in temperature na nangyayari sa heat transfer. So for example, lagyan natin ng thickness tong pipe natin. So ayan po. Bale yung una is ito yung radius inside. Indicate natin siya na Ri. And then yung pangalawa is yung RO or radius for the outside. Then also, kaya nga nagkakaroon ng heat transfer dahil meron tayong temperature difference. So, yung temperature at this point, yung sa radius ng inside, yun yung magiging temperature inside natin. And of course, yung outer surface, yun yung magiging temperature outside natin. So, integrate natin siya from Ri, Ro, from T inside, T outside. So now, let's solve Q dot. So, integral po ng dr over r is ln r. From limit po is Ri to, lagyan natin kulay red, Ri Ro equals, constant po natin, sulat natin as is, negative k 2 pi l, and then derivative po ng dt is simply as t. Pero may limits po siya na ti inside to. Therefore, substitute natin yung mga limits. Magiging q ln ro minus ri equals negative k 2 pi l to minus ti. So, yan po. So, remember na sa ating logarithmic law, we can write this form into, if for example, meron tayong ln a minus b. We could write this in the form of ln a over b. So, gagawin po natin siyang ganito to simplify it further. So, q ln ro or radius outside over radius inside ri equals negative k 2 pi l to minus ti. And then, isolating po natin yung isolate natin yung q on one side. Heat transfer po, magiging q equals negative k 2 pi l to minus ti over ln ro over ri. So, ito na po yung formula natin ng heat transfer through cylinders. Pero hindi pa po dyan nagtatapos. Hindi pa po mas madaling mag-solve pag alam natin yung resistance. Kasi mas magandang habang nagsosolve ka, say for example, marami tayong multi-layered ng walls ng pipe or marami tayong multi-layers ng insulation, it is much better na solve muna yung mga thermal resistance. So in this case, makikita natin na ang thermal resistance natin is ito pong bibilugan natin. Just may iwan yung Q saka yung temperature difference. So ang magiging thermal resistance for cylinder is ln R outside over R inside over negative K, or sulat na lang natin, unahin natin yung 2 pi KL para medyo madaling pong i-memorize. So, magiging final formula natin for heat transfer through cylinders is Q equals TO minus TI over R cylinder or thermal resistance through cylinders. So ito lang naman yung kadalasang minimemorize natin dahil pareho lang din po siya sa conduction through plane walls pero nagbabago lang yung thermal resistance. So take note, RO outside, RI inside. So paano pag nagkaroon na ng dalawang insulation or tatlong insulation? So magkakaroon tayo ng tatlong radius din. So pakitandaan, ito lang po yung indication na ito yung outside, inside. Then pag marami na tayong multi-layered na tayo, magiging numbering na lang po yan. Laging tandaan na ang nasa numerator ay yung mas malaki or yung nasa outside over yung susunod na mas maliit na radius. Ganon din po sa temperature, outside and inside. Bawat po layer po nagkakaroon po tayo ng temperature. So yung outside lagi yung pinakamataas minus yung pinakamababa. So yan po yung formula natin for cylinder. So next, for spheres naman tayo. So next, conduction through spheres. Same lang din po siya sa conduction through cylinder, pero ang nagbago lang po is yung circumferential area niya or yung area niya sa Fourier's law. So pakitandaan na lang po, ang area po natin or cross-sectional area po natin for sphere is 4 pi r squared. So let's try to solve for the formula for spheres. So Fourier's law po ulit. Negative Ka dt over dr. Substituting the cross-sectional area for sphere. Negative K times 4 pi r squared dt over dr. So solving for this equation, let's separate the variable first. Q cross multiply dr over r squared equals negative K 4 pi dt. So integrating na naman siya from point 1 to point 2 or from inside to outside. Inside, outside, temperature inside, temperature outside. So integrating both sides, magiging Q negative 1 over R with limits of Ri and Ro equals negative K 4 pi T limits po niya Ti and To. So yan po ang kalalabasan after natin i-integrate. Then substituting yung mga limits, Q equals or bracket muna negative 1 over ano yung unang limit na gagamitin natin, which is yung R yung R outside minus 1 over, huwag kakalimutan minus pero may negative po dito dahil po nanggaling po dito yung negative na yun, R inside equals negative K 4 pi To minus Ti. So isolate na lang ulit natin yung Q para makuha natin yung formula for spheres. Q equals negative K 4 pi To minus Ti T inside over 1 over RO negative, ay negative po, plus, magiging plus po, negative times negative, magiging positive, 1 over RI. So, simplify natin further. Q was negative, unahin natin yung 4 pi na lang, K TO minus TI over 1 over RI minus 1 over RO. So, mapapansin natin na ito na yung final formula natin for conduction through spheres. And then, makikita natin na ang thermal resistance natin, pag i-isolate po natin ito sa temperature difference or yung TO minus TI is thermal resistance for sphere is 1 over Ri minus 1 over Ro over negative 4 pi K, which can be simplified pa. Simplify pa natin. Pwede natin ipag-minus to. So, thermal resistance ng sphere is Ro minus Ri over yung LCD po nila, Ri, Ro over 4 pi K, or mas simplified po, pwede nating i-reciprocal. Magiging Ro minus Ri over 4 pi Ri Ro K. Yan na po yung thermal resistance natin for sphere. So, take note po, yung pinagkaiba ng thermal resistance ng sphere at ang thermal resistance ng cylinder, which is ln Ro over Ri divided by negative 2 pi KL. So, yan lang po. Ito po yung mga the best na tandaan na formula. Instead po yung mahaba. Dahil yun nga po ang concept natin sa heat transfers, parang sa electrical circuit na meron tayong voltage, ampere, saka resistance lang. Pero yung resistance natin, yun yung mga nagbabago lang yung formula. So, it is much better na, mali po pala, Ri po pala dito. Ayan, much better po na tandaan na lang po natin yung mga resistance. So, next, sample problem na po tayo para mas maintindihan natin yung mga formula or paano gamitin yung mga formula. Problem number 1. A steel pipe with 5 cm outer diameter is covered with a 6.4 mm asbestos insulation with K of 0.096 BTU per hour feet degree Fahrenheit, followed by a 2.5 cm layer of fiberglass insulation with thermal conductivity of 0.0288 BTU per hour feet degree Fahrenheit. The pipe wall temperature is 315 degrees Celsius and the outside insulation temperature is 38 degrees Celsius. Let the length of the pipe be 1 meter. Solve for the following: heat flow or Q dot and the interface temperature between fiberglass and asbestos, which is yung T2. So, given. Lahat ng given, nandyan na. Sulat lang natin. given 5 cm outer diameter. Yun yung diameter po ng pipe. So, diameter 1 is 5 cm. So, ang radius niya is 2.5 cm or 0.025 meters. And then, is covered with a 6.4 asbestos insulation. Meron daw siyang sumunod na insulation na asbestos which is 6.4 mm. Yung thickness po, hindi po radius. So, kung ito-drawing natin yung diagram natin ng pipe, ito po, yung nauna is yung steel which has a radius of, yun yung R1 natin, radius of 0.025 meters, and then sinundan daw po siya ng asbestos. So, magkakaroon na tayo ng R2. So, paano natin hanapin yung R2? Ang given is thickness lang. So, i-add po natin yung thickness na sinabing 6.4 sa R1. So, ang R2 natin is R1 plus 6.4 mm. So, divide na natin sa 1,000 para maging meters. And i-add na lang natin. Cancel meters. So, magiging R2 natin is 0.0314 meters. Then next na insulation daw followed by a 2.5 centimeter layer of fiberglass insulation. So, pag idadagdag natin dito sa drawing natin, magkakaroon na po tayo ng R3. Which is may thickness daw siya na 2.5 cm. So, to get for the R3, we need to add the thickness and yung radius na R2. So, R3 is equals to R2 plus thickness na 2.5 cm. Di-divide na natin siya ng 100 para maging meter. So, our answer for R3 is 0.0564 meters. So, ayan na po yung mga radius natin na gagamitin. So, next, ano nga po yung mga thermal conductivity ng ating mga insulation? Given po na una natin insulation is Ka for asbestos which is 0.096 BTU per hour feet degree Fahrenheit. Then, sumunod na insulation natin, Kf for fiberglass which has a thermal conductivity of 0.0288 BTU per hour feet degree Fahrenheit. So, yan. And then, yung temperature daw po natin sa inside, mababasa po natin, the pipe wall temperature is 315. So, yan po yung temperature dito sa inside. Yan yung T1 or TI, which is equals to 315 degrees Celsius. Digit natin as T1. And yung temperature natin sa outside is 38 degrees Celsius. So, dito po yun. Yung temperature sa outside, T outside or yung T3 po. Bakit T3? Kasi po sa problem is pinapahanap yung T2 natin, which is yung T2 is yung nasa gitna po. Ito po, in between ng asbestos and fiberglass. So, ito po yung T2 na hahanapin po natin sa letter B. Ayan po. Hindi po pala nakita ito. Unit po nito is, yan, 0.0288 BTU per hour feet degree Fahrenheit. Okay. So, now, given na po lahat, solve po na po natin yung mga thermal resistance. So, unang thermal resistance natin is in between yung steel pipe saka yung asbestos. So, R1, sulat na natin yung thermal resistance formula natin for cylinder, which is ln. Tandaan, ang RO o yung pinaka nasa outside, in between nung dalawang material muna. So, R2 over R1 divided by 2 pi KL, which is yung L is yung which is yung K pala is yung K for asbestos. So, lagyan natin ng A po dyan. Makikita po natin na dalawa lang ang thermal resistance po dito, which is yung in between ng naunang radius na R1, R2, saka yung R2 at R3. So, dalawa lang po ang thermal resistance po natin. So, substitute natin para makuha natin yung R1. Ln R2 is 0.0314 meters over R1, 0.025 meters divided by 2 pi, ano po yung K ng A is 0.096 BTU per hour feet degree Fahrenheit. Ayan po. Then, multiply natin ng length. Take note, yung length na given natin is in meters. So, convert na lang natin. 1 meter is equals to 3.28 feet. Para mag-cancel po yung feet dito sa thermal conductivity ng asbestos. So, solving for R1, makukuha natin is 0.1152 R degree Fahrenheit over BTU. So, nakasolve na po natin yung R1. Next, solve natin yung R2. So, resistance, thermal resistance, R2, magiging ln. Yan po. Tandaan, nandun na tayo sa second, insulation or yung material. So, magiging pinaka-outer radius natin is R3. Tapos, inner is R2. So, R3 over R2 divided by 2 pi K. Anong K po gagamitin? Yung in between ng R3 at R2, yung K po ng fiberglass, which is 0.0288 BTU per hour feet degree Fahrenheit. So, sulat natin KF times length ng pipe, which is constant na 1 meter or 3.28 feet. So, now let's substitute the values. Ln R3, 0.0564 meters divided by R2, which is 0.0314 meters over 2 pi K ng F or fiberglass is 0.0288 0.0288 BTU per hour feet degrees Fahrenheit times 1 meter or 3.28 feet. So, calculating these values, we could get the thermal resistance for R2 at 1.0149 R degree Fahrenheit over BTU. So, ano pong mapapansin natin? Ano pong gagawin natin sa R1 at R2? Sila po ay in series or connected sila in series. Kasi kung isusulat po natin yung kanilang parang thermal circuit, makikita po natin na may given lang po na dalawang thermal conductivity, which is yung asbestos at yung fiberglass. So, alam na po natin kapag in series po ang dalawang thermal resistance, i-add lang po natin sila. So, ang R total natin is R1 plus R2, which is, pag pinag-add po natin, makukuha nating value is 1.1301 R degree Fahrenheit over BTU. So now, pwede nating isolve yung A natin, which is yung heat flow. Lagay na lang po natin dito, no? Alam natin na ang formula is Q, laging Q equals T outside or T3 in this case minus T inside or T1 po over yung R total o yung total thermal resistance natin. So substitute lang natin T3 natin given at T3 and T1. Mas madali po pala para positive ang sagot natin. Gawin na lang po natin na T1 minus T3 over R thermal resistance. Bakit po? Kasi mas malaki po pala yung temperature natin sa inside kaysa sa outside. Therefore, yung flow ng heat natin is from inside going to the outside. Yan po. Kaya po, magiging inside minus outside para po positive yung magnitude ng heat natin. So, substitute lang natin. 315 degrees Celsius minus 38 degrees Celsius over our total natin is 1.1301 R degree Fahrenheit over BTU. So, yan po. So, mapapansin po natin na ang temperature natin is naka degrees Celsius tapos yung R natin, yung thermal resistance natin is naka degree Fahrenheit. So, kailangan nating i-convert yung temperature ng 315 at 38. Pero may shortcut po akong tuturo sa inyo para mas mabilis. I-multiply lang po natin sila ng 1.8 degree Fahrenheit over degrees Celsius. Ito pong conversion na to is para sa change in temperature lang po. Okay? So, magagamit mo lang to kapag mayroon kang pinag-minus na temperature or change in temperature. So, itry nyo na lang din para maniwala kayo. I-convert nyo na lang muna tong dalawa individually. Tapos, isolve nyo. Dapat ang makukuha nyo, same lang na 441.2 BTU per R. Ayan po ang final answer natin for letter A. So, tandaan po ang conversion na to is for change in temperature lang po, which is 1.8 degree Fahrenheit equals to 1 degree Celsius na change in temperature. So, next, letter B. So, letter B po for problem number 1. So, in letter B, we have to find for the interface temperature between the fiberglass and the asbestos, which is yun yung T2. So, if we will write again yung diagram natin kanina, ito po yung R1, steel, R2, sa asbestos, and then R3, ito po yung for the fiberglass, and then meron tayong T1. Yung T1 natin is inside. Next, yung T2. Then, lastly, yung pinaka-outer is yung T3. So, yan po. Ito yung values po ng mga T1 at T3. And, kinonvert na lang po natin para mabilis po yung pag-solve natin. So, we would like to find for the temperature 2, yung nasa gitna po. In between ng asbestos and yung fiberglass. So, paano po natin hanapin yon? So, basically, alam po natin na ang heat in one dimensional is steady state flow. So, yung heat is going to this direction from the hottest side na T1, which is 315 degrees Celsius or 599 degree Fahrenheit to T3 na 100.4 degree Fahrenheit. So, solve na natin yung T2. Solution, sulat natin yung formula for heat flow, which is meron dapat T2. So, magiging T1 minus T2 hanggang T2 lang yung sinosolve natin. So, ano magiging thermal resistance natin? Thermal resistance natin, yung may thermal conductivity, which is yung asbestos lang. So, ang magiging thermal resistance natin is yung R1 lang po para mahanap si T2. So, substituting the values, 441.2 BTU per hour equals T1, which is 599 degree Fahrenheit minus T2 over R1. Na-solve na po natin yung R1, which is 0.1152 BTU per mali po pala R degree Fahrenheit over BTU. Yan po, para mag-cancel pag nag-cross multiply po tayo dun. R. So now, solving for T2. Solve natin si T2. Ginamitan natin ng shift solve. Solve natin na T2 is 548.1738 degrees Fahrenheit. Yan po. So, mapapansin natin na mas mababa yung T2. Mas bumaba dahil nga po meron siyang dinaanan na thermal resistance. So, ibig sabihin nabawasan yung along the way, nabawasan yung heat. And yung temperature natin dun sa T2 is naging 548.1738 na lang. So, alternative solution, pwede pa natin i-solve yan using T2 at T3. Q equals to T2 minus T3. Nauna yung T2 kasi mas mataas dapat yung T2 kaysa T3. Kasi nga yung heat manggagaling dito sa inside of the pipe going to the outermost part of the pipe. So, ang gagamitin lang natin na thermal resistance is yung thermal resistance ng fiberglass, which is R2. So, substituting the known values, 441.2 BTU per hour equals to T2, which is the unknown, minus T3, 100.4 degree Fahrenheit over R2. Solve na natin from letter A, which is 1.0149 or degree Fahrenheit over BTU. So, substituting and solving, calculate na lang natin. Shift solve. Ang T2 is same dapat na 548.1738 degrees Fahrenheit. So, yan. Tapos na po yung problem natin for problem number 1. So, take note, in conduction through cylinders and spheres, yan nga, basic concept is Fourier's law. Gagamitin lang natin si Fourier's law and tandaan natin yung mga thermal resistance for cylinders and spheres. And pakitandaan, isang tandaan din po syempre yung mga area, circumferential area or cross-sectional area pag cylinder saka sphere. Pag cylinder, 2 pi RL. Pag sphere naman, 4 pi R squared. Tandaan po yan kasi importante po yan for our next topic, which is convection. Dapat memorize po natin yung mga area ng different shapes or different shapes po para sa ating heat transfer, yung mga material na pwedeng daluyan ng heat. So, yun lang po. Good luck and God bless.